Science in pajamas. Woo! I know it's been a while since I've made one. Just been busy with the beginning of the school year, but here we are. This is my virtual classroom. So today we are actually going to talk about forces. Now, forces, the quick definition of it is a force can be a push or a pull. So it's when one object enacts or interacts with another and it results in this push or pull sensation. For instance, let's see, what can I put? Here we go. I have this little ball in my hand. I can push it, and the force I use to push it. Oh, sorry about that. Thank you. The force I use to push it or to pull it causes it to move. So that's just what a force is. Now there's different kinds of force. There's physical force like this, where if I want it to move, I have to actually physically touch it. But there's also field forces, such as gravity. The little ball does not have to be touching the earth to experience the pull of it due to gravity. So if I toss this up, it comes back down. And that's because with gravity, you have an object with such large mass that it creates this field around it, this invisible field. And when another object of mass enters that field, it experiences a pull towards the larger object. That's all gravity is. So we are objects of smaller mass. The Earth is an object of larger mass, and we are within its field. That's why if you're away from the Earth and just in the middle of space, you just kind of float there. Not as much gravity. Because you're not in the field that's generated by a larger object. So we have field forces, we have physical forces. Let's talk about how we measure them a little bit. Now we are going to have videos on Newton's first, second, and third law of motion because they deal a lot with forces and how they affect motion. But right now we're just doing a quick introduction. Now a force, depending on the type, can be measured by all different manners. Like we mentioned, there's gravitational force, electric force, magnetic force. Those are three of the field forces. And then we have any number of physical forces. Like I said, me pushing on that little ball. A soccer player kicking the soccer ball. A car driving down the road. A dog chasing a squirrel. The squirrel hanging on to the branch. I mean, there's lots of different forces going on, and they all interact. So we can measure them, though, and they do have their own unit. There's my marker. So the unit for a force is called the Newton. So the SI unit is the Newton. Yes, it's named after Sir Isaac Newton. That's a little bit better. All right, so it's named after Sir Isaac Newton, and it is equal to, so 1 Newton, we abbreviate it with a capital N. So 1 Newton is equal to 1 kilogram times 1 meters per second squared. So sometimes we can think about that as a Newton equals kg times m over s squared. Now, if you're wondering where that comes from, we're definitely going to cover that in the video for Newton's second law, because that deals with an equation. Some people in the science and even Star Wars nerddom might know the equation for it. F equals m times a. And the reason why I say in the Star Wars nerddom is because, they say like, may the force be with you. So I've seen shirts and all that say, may the mass times acceleration be with you. So, just fun little nerdy stuff. Now, if an object has no net force acting on it, that actually does not mean that it is at rest. All right, so this one is not good for this board. Good to know. I'm learning a valuable lesson about some of my markers. I'll clean it off later. All right, so let's see. All right, let's try red. So if an object, let's say a car, is experiencing, oh, that is way too light. So we have our object. And it is experiencing a net force of 0. So net force equals 0 newtons. That does not mean that it's at rest, that it's just sitting on the ground. What it means is that all of the forces around it are kind of balancing out. So it could be moving at a constant velocity. If this car is moving in a straight line with a constant velocity of 30 meters per second forward, now, since it's moving at a constant velocity, remember what we said, that force equals m times a. Force equals mass times acceleration. So if there's no acceleration, that means that there's no net force. Because if there's no acceleration, that means that's 0. 0 times mass would be still 0. So it doesn't mean that there is no force. It means that there's no, it doesn't mean that there's no motion. It just means that the different forces are all balancing out. So it's experiencing the applied force of 30 meters per second. It could be experiencing a frictional force as well, and then there's gravitational force, normal force. So it's experiencing all these to the point where the force itself cancels out. So they're balanced. Since they're balanced, it's just going to go at a nice constant velocity. If one of the forces increases, then that would cause the car to increase its velocity, which means that now we have an acceleration. So now we have a new force. We have extra force. And then we would see that it's no longer balanced out. So just kind of wanted to talk about that. In the next video, we will talk about Newton's first law of motion. But in the meantime, you guys just stay awesome, stay safe. All right, we'll talk to you next time. Bye-bye.